This video is only for the integral of e to the x times sine of 2x times differential of x, because whenever you have an exponential function and a trigonometric function, you can obtain a cycle, so it's quite long, so be patient. Here we have the formula. The integral of u times differential of v equals u times v minus v times differential of u, and the exercise we're going to work with. I have written the integral here, and now we're going to start by making a choice for u, which is going to be e to the x, and a choice for the differential of b, which is going to be sine of 2x times dx. Then the difference is pretty easy because differential of u equals e to the x. For b, we need the integral of sine of 2x times differential of x. We have a formula for this. All we have to do is to make a changing variable for the argument. So u equals 2x times dx. U equals only 2x, and its differential will be 2 times dx. We're going to divide by 2, and then we're ready to find the integral. So the function b will be 1/2 times the integral of sine of u times differential of u. And the integral of sine is negative cosine, so I'm going to write the negative here, and then 1/2 cosine of 2x, and remember that I'm not writing the constant here. Now the substitution. So the substitution will be u, which equals e to the x times differential times b, which equals negative 1/2 times cosine of 2x, minus the integral of b, which equals negative 1/2 cosine of 2x times differential of u, which equals e to the x times dx. I need to erase part of this in order to continue with the integral. I am going to rearrange some of these numbers, so it's going to be negative 1/2 e to the x cosine of 2x plus the integral of 1/2 e to the x cosine of 2x times differential of x. As you can see, we have an integral here that we have to work with. And for this integral, we need integration by parts again. So I'm going to change the color in order to help you. So we need a choice for u, and I'm going to do the same, e to the x. Its differential will be e to the x times dx. And the right choice for differential of b will be cosine of 2x times dx. We need to do the change of variable for the argument, so I hope you remember easily how to do this. We need a change of variable for the argument, so this will be 1/2. Since the integral of cosine is positive sine, that will be 1/2 times sine of 2x. And then we have all the elements for this integral. Now I'm going to continue writing the integral by saying that this equals negative 1/2 e to the x times cosine of 2x. But I have to write pretty small numbers because it is a long integral. So I want you to remember the formula. Remember that we're going to make for this integral, we're going to make u times b minus b times differential of u. I mean, u times b minus the integral of b times differential of u. So let's continue. That will be plus, and then I'm going to use parentheses in order to avoid mistakes. But before that, let me go back a little bit. I'm going to write the constant 1/2, and then I'll write the parentheses. Now, remember to multiply u times b. And then we're going to subtract the integral of b times du, which is e to the x times dx. And I'm going to close these parentheses. I'm gonna stop a little bit here because I want you to see something that is quite important for this type or this kind of integrals. As you can see here, we have another integral to obtain, but I would like you to see that this is sine of 2x times e to the x. But this is the one we had at the beginning. E to the x times sine of 2x times dx. If you remember at the very beginning of this video, I told you that whenever you have an exponential function, a trigonometric function, you're going to obtain a cycle. Here's where the cycle appears. I have the same integral again, so I'm going to show you what to do. First, let's rewrite part of this. This will be negative 1/2 e to the x cosine of 2x plus 1/4, because we're going to multiply the 1/2 times 1/2, and then this half multiplies this one. We're going to do 1/2 times 1/2 and 1/2 times 1/2. So let's continue. That will be 1/4 e to the x times sine of 2x. And then, since we have a positive sign here, a negative one here, we're going to do positive times negative is going to be equal to negative 1/4, because I told you before about the product, 1/4 the integral of e to the x times sine of 2x times dx. And I want you to see now clearly how we have here the same integral we had at the beginning. So what do we have to do? First, I'm going to write here the integral we're working with, which is e to the x times sine of 2x times dx. And then, again, I'm going to use this little hand to show you that we have one term or a common term here in the left side of the equation and the common term here in the right side of the equation. So what are we going to do in order to end and to finish this integral? Well, it's pretty easy. I'm going to add in the right side of the equation 1/2 of the integral of e to the x times sine of 2x times dx. And I'm going to do the same in the left side of the equation. That will be plus 1/4 integral of e to the x times sine of 2x times dx. As you can see, if we add in both sides of the equation the same amount or the same quantity like this, we keep the balance, we keep the equal sign. So negative plus positive 1/4 times the integral of e to the x sine of 2x times dx, we're going to obtain 0 in the right side. And here we're going to obtain, and I'm going to write it because we have here 1 time the integral of e to the x and so on. So I'm going to add 1 I'm going to add 1 plus this 1 plus 1/4 in order to finish this left side, and here I'm going to obtain 0. So let's do it. If we do 1 plus 1/4, that would be 5/4 of the integral of e to the x times sine of 2x times the x. And that equals negative 1/2 e to the x cosine of 2x plus 1/4 e to the x sine of 2x. But we're missing something because we were looking for the integral of e to the x sine of 2x. We were not looking for 5/4. So what do we have to do now? We have to multiply both sides of the equation. We're going to multiply by 4/5. And we're going to do the same with the right side. We're going to multiply by 4/5. Are you tired? Well, me too. But we're almost done. So if we multiply the left side here, if we multiply coefficients, 5/4 times 4/5 equals 1. And then we have to multiply 4/5 times negative 1/2 and 4/5 times positive 1/4. So if we do that, we're going to be ready and done with this integral. So let's finish it. As we said, this product equals 1, so we're going to obtain the integral of e to the x sine of 2x times dx. And then all we have to do is to multiply the coefficients. Remember, 4/5 times negative 1/2 and 4/5 times positive 1/4. And that will be done. That will be it. So this is negative 4/10 e to the x cosine of 2x plus 1/4 times 4/5. That will be simplifying. Well, I will not simplify. I'll simplify at the end. 4/20 times e to the x times sine of 2x plus the constant. So finally we got to the end. We're going to simplify this fraction. This would be 2/5 of e to the x cosine of 2x plus 1/5 times e to the x sine of 2x plus the constant. And after all this work, we're done. I know you're going to have questions because this is a pretty long, I mean, it's not difficult, but it's a long exercise. You should try to watch this video but making stops, okay? So watch part of it and then stop and then go back to the video and check your understanding, and then you will continue with the next part, make a stop and check your understanding, and go like this till the end of the video, okay? Hope it helps you.